Hello. Today we are going to start a new lesson, that is limits and continuity. First we will discuss about the synopsis. Actually there are not many points. In limits and continuity chapter, there are a few formulas, and that is, I'll write down a few. One by one you can see and you have to learn them. The first one is limit of sine theta by theta as theta approaches 0 is 1. Similarly, limit of tan theta by theta as theta approaches 0 is 1. Limit of cos theta as theta approaches 0 is 1. Limit of x power n minus a power n by x minus a as x approaches a is n into a power n minus 1. Limit of a power n as n approaches infinity is infinity. If a is greater than 1, but it is 0 if a is less than 1. Then limit of 1 plus x power 1 by x as x approaches 0 is e. Limit of a power x minus 1 by x as x approaches 0 is log of a base e, or ln of e. Limit of f of x by g of x as x approaches a is limit of f of x as x approaches a by limit of g of x as x approaches a. Limit of f of x by g of x as x approaches a is equal to limit of f prime of x by g prime of x as x approaches a, but the condition is f of a and g of a both should be equal to 0. So this formula I can extend to limit of f double prime of x by g double prime of x as x approaches a if f prime of a is equal to g prime of a equal to 0. Like that I can go more further and further. This rule which I wrote, that is called L'Hopital's rule. L'Hopital's rule, which I wrote in the previous page. So whenever L'Hopital's rule means what? If you take limit of f of x by g of x as x approaches a, and if you put f of a by g of a, if you get 0 by 0 or infinity by infinity, then L'Hopital's rule is applied. And I told you what is L'Hopital's rule. What I will do? Limit of f of x by g of x as x approaches a is the question. So that will be equal to limit of f prime of x by g prime of x as x approaches a. But suppose if you directly put a, f prime of a and g prime of a, if you get 0 by 0 or infinity by infinity again. So again L'Hopital's rule is applied. L'Hopital's rule means you will take limit as x approaches a f double prime of x by g double prime of x. Suppose if I put directly a into it, f double prime of a, g double prime of a. And suppose if I get 0 by 0 or infinity by infinity. Infinity by infinity. So again I have to apply L'Hopital's rule. So this process continues. While doing in problems, you will understand. For example, I am giving one question, limit of b by a minus bx plus a by bx square minus ax as x approaches a by b. So how to simplify this? We can write this as limit as x approaches a by b by a minus bx plus a by, I can take x common. So when I take x common, I have minus a plus bx. Or I can write this as x approaches a by b by a minus bx plus a by so instead of plus a, I will take minus, so that I will have minus a by x into a minus bx. So you can see that denominator we can take common. We can take a minus bx and x common. So that means b you have to multiply by x and minus a you have to multiply with nothing. Minus a you will multiply with nothing. So this can be written as limit as x approaches a by b. You can write minus outside. So a minus bx and down in the denominator x into a minus bx. So a minus bx and a minus bx will cancel. We have limit of minus 1 by x as x approaches a by b. So you will have minus 1 by a by b or minus b by e. That's the final answer. Similarly, we will take another problem. Limit of x square minus a square by x cube minus a cube as x approaches a. If I put a directly, I will get a square minus a square by a cube minus a cube, which is 0 by 0. So I have to apply L'Hopital's rule. As per this rule, I will write limit as x approaches a. I will take the derivative of the numerator. Derivative of the numerator is 2x because a square's derivative will be nothing. A square's derivative is 0. A square is a constant. Denominator x cube derivative is 3x square and a cube is a constant, so its derivative will be 0. So you can remove 1x. That means you have limit 2 by 3x as x approaches a. So in place of x, now you can put 3a. Two by 3a is the final answer. Each problem will be of different type. Suppose if you take question like this, limit of x square minus a square by x minus a as x approaches a. If you put directly, you will get a square minus a square by a minus a, which will be 0 by 0. So we will try any other method. The method I want to try here is x square minus a square. I can write x plus a times x minus a. I am factorizing, and denominator we have x minus a. So x minus a cancels. Now when you are cancelling, you're left with x plus a as x approaches a. You can put a plus a and that will be 2e. 2a is the answer. Let's go to the next question. Limit of e power x minus 1 minus x square over 2 by x cube as x approaches here. So what we can do, or what we have to do, is we will write the expansion of e power x. E power x is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. So in the limit, I will put that. E power x is 1 plus x square by 2 factorial plus x cube by 3 factorial, so on. And then you will have whatever is left of, that is minus 1 is there. Then minus x is there, minus x square by 2 is there. And then finally you have x cube in the denominator. Now what happens is 1 and minus 1 cancels, x and minus x cancels, x square by 2 factorial and minus x square by 2 factorial cancels. So left is x cube by 3 factorial plus x power 4 by 4 factorial and so on by x cube plus x square. So in denominator, we will just write x cube. This is what we have. Now, as x approaches 0, what I can write is, I can write this limit as x cube by 6 plus x power 4 by 24, and after that x power 5 by 120, and so on it will continue, and denominator x cube. If you put 0 directly, you will get 0 by 0. You will get 0 by 0. So you can apply L'Hopital's rule. How many times you will apply, you see here. You will have 3x squared by 6 plus 4x cubed by 24 plus 5x power 4 by 120, and so on. In denominator, you will have 3x squared. Now, still, if you put x as 0, you will get 0 by 0. But here, 3 2s, 4 6, 5 24s. This is what you have. Still, when you put x as 0, you will get 0 by 0. So again, we can apply L'Hopital's rule. So when you apply L'Hopital's rule in the numerator, you have 2x by 2. And then next term will be 3x squared by 6 plus next term will be 4x cubed by 24. 4x cubed by 24, and then this continues. In denominator, the derivative is 6x. So you can cancel 2 and 2, 3 ones, 3 twos, 4 ones, 4 6. But if you put x, again you will get 0 over 0 if you put x as 0. So apply L'Hopital's rule again. 1 plus 2x by 2 plus 3x squared by 6, and so on, and in denominator 6. Now when you put x as 0, you will have 1 by 6. This is a little bit long problem, but it is easy. Okay, next sum is limit of root of x plus h minus root of x by h as h approaches 0. How to do this? You can go for rationalization. That is, up and down, you have to multiply with the conjugate. Square root of x plus h plus square root of x. Down also square root of x plus h plus square root of x. Then you will have limit h approaches 0, x plus h minus x in the numerator, and h into square root of x plus h plus square root of x. So x and minus x cancels. You will have limit of, as h approaches 0, h by h into square root of x plus h plus square root of h. H and h cancel, square root of x here. So you are left with limit as h approaches 0, 1 by square root of x plus h plus square root of x. Now you can put h as 0. So you have 1 plus square root of x plus square root of x. And that is 1 by 2 times square root of x. The next type is limit of 2x cube plus 4x square plus 5 by 4x cube minus 3x plus 7 as x approaches infinity. For that you have to take highest power x cube's coefficient, that is 2 by 4 or 1 by 2. F of x is given as absolute mod of x by x. X is not 0. So the question is, you have to find limit of f of x as x approaches 0 minus. You have to find limit of f of x as x approaches 0 plus. And hence you have to find limit of f of x as x approaches 0. All these three. So first of all, I will write the function. The function is a piecewise function. So it will be equal to, in two parts, when x is less than 0, then I will have minus x by x, that is minus 1. But suppose if x is greater than 0, then I will have x by x equal to 1. So when I take limit of f of x, x less than 0, I have to take minus 1. When I take limit of f of x when x is greater than 0, 0 plus, it is 1. So left limit is not equal to right limit. If left limit is not equal to right limit, then limit of f of x as x approaches 0 does not exist. D and E means does not exist. So from this, you can learn one thing. Limit of f of x as x approaches a exist if limit of f of x as x approaches a minus will be equal to limit of f of x as x approaches a plus. Left limit will be equal to right limit because Shashi Kapoor's limit of f of x as x approaches a exist if limit of f of x as x approaches a minus is equal to limit of f of x as x approaches a plus. That is, left limit is equal to right limit. Otherwise, the limit does not exist. This is what we came to know with this problem. Then we will learn about greatest integer function. Limit of greatest integer function x as x approaches c is c. If c is not an integer, if c is an integer, then what happens is limit of greatest integer function as x approaches c minus will be c minus 1, and limit of greatest integer function as x approaches c plus will be c. Here left limit is not equal to right limit. So limit of greatest integer function x as x approaches c does not exist. I can see that. Now there is something called squeeze theorem. According to this, if you are given limit of f of x as x approaches a is L, and limit of h of x as x approaches a is also L. Suppose if g of x is greater than or equal to f of x and less than or equal to h of x, then limit of g of x as x approaches a will be greater than or equal to limit of f of x as x approaches a and less than or equal to limit of h of x as x approaches a. Now limit of f of x is L. So limit of g of x we don't know, we are finding. Again, limit of h of x as x approaches a is L. That means limit of g of x as x approaches a is, I have to take between L and L, which is not possible. Between L and L, we can't find any number. So we have no other alternative but by squeeze theorem, limit of g of x as x approaches a, that will be equal to L only. Because this side L, this side L, equal to L, no other alternative. This is only called squeeze theorem. Then some important things you have to learn. Limit of 1 by x as x approaches 0 minus is minus infinity. Limit of 1 by x as x approaches 0 plus is positive infinity. So limit of 1 by x as x approaches 0 does not exist. That means we can't find the limit. The next one, if limit of f of x as x approaches a is L, then limit of mod of f of x as x approaches a is mod of. The next is continuity. You can say that f of x is continuous, especially at x equal to a, if limit of f of x as x approaches a minus is equal to limit of f of x as x approaches a plus is equal to f of a. Or in other words, we can combine these two and write limit of f of x as x approaches a is equal to f of a. This also can be condition for continuity. Then we can say that the function is continuous. All polynomials, no doubt, they are continuous. All polynomials are continuous. And then one more thing you can say, sine x, cosine x are also continuous. Now, there are types of discontinuities. Types of discontinuities. One is the graph will have a hole at x equal to c. So what happens here is f of x is not defined. But limit of f of x as x approaches c plus is same as limit of f of x as x approaches c minus. So this happens when there is a hole in the graph at x equal to c or removable discontinuity. Hole, or I can say removable discontinuity. So this is one type of discontinuity. The other type of discontinuity is like this. So this happens at x equal to c. So what you can see is suppose here you have L, here you have M. So what I can write is f of c is L. If f of c is equal to L, you can see that limit of the function as x approaches c minus is L. And limit of the function as x approaches c plus is M. So what is happening here? F of c is L, left limit is L, but right limit is not L. So left limit is not equal to right limit. That means limit of the function as x approaches c does not exist. So if this happens, we call this as non-removable discontinuity. Or we can even say this is jump discontinuity. In this way, we completed the synopsis part. We can go to the problems, questions. I'll start with first question. The first question is limit of 1 by x minus 3 plus 9x by 27 minus x cube as x approaches 3. So I will factorize the first denominator will be same. I cannot change the first denominator. I will change only the second denominator. So how to change the second denominator? Factorizing. Limit as x approaches 3, 1 by x minus 3, 9x by. This plus I will make it as minus and write x cube minus 27. That means I have limit as x approaches 3, 1 by x minus 3 minus 9x by x cube minus 27's factor is x minus 3 into x square plus 3x plus 9. So after factorizing, we can take common denominator. Common denominator is x minus 3 into x square plus 3x plus 9. So that means you will have x square plus 3x plus 9 minus 9x. Or that is, I have limit x approaches 3, x square minus 6x plus 9 by x minus 3 into x square plus 3x plus 9. Numerator I can factorize. I can write x minus 3 into x square minus 3. Sorry, x minus 3. X minus 3 into x minus 3. Numerator I can factorize. Then in denominator I have x minus 3 into x square plus 3x plus 9. So 1x minus 3 got cancelled. Now if you plug x as 3, if you put x as 3, 3 minus 3 by 9 plus 9 plus 9. So you will just have 0. Let's go to the second question. Limit of x square plus 2x minus 15 by x square minus 5x plus 6 as x approaches 3. Directly if you plug 3, 9 plus 6, 15 minus 15 will be 0. And in denominator, 9 minus 15 plus 6. That is still I am getting 0. So I can apply L'Hopital's rule. Derivative of numerator is 2x plus 2 and derivative of denominator is 2x minus 5. Put x equal to 3 and 6. 6 plus 2 is 8. And denominator 6 minus 5 is 1. So the answer will be 8. Let's go to question number 3. Limit of x cube minus 1 by x minus 1 as x approaches 1. If you put x as 1, 1 minus 1 by 1 minus 1, you will get 0 over 0. So what to do here? I will factorize the numerator. X minus 1 into x square plus x plus 1 by x minus 1. I can cancel x minus 1 and then put x as 1. 1 plus 1 plus 1. 3 will be the answer. There are many methods. You can select any one method, whichever you are convenient with. Okay. Next question. Limit of x power minus 3 minus 2 power minus 3 by x minus 2 as x approaches 2. I gave you one formula, n a power n minus 1. That is minus 3 power minus 3 into 2 power minus 4 or minus 3 by 2 power 4 or minus 3 by 16. So using formula also we can sometimes get the limit. The next limit is limit of log x minus 1 by x minus e as x approaches e. If you directly put here log e, you will get 1 minus 1 and e minus e. This is what you have. So direct substitution is not possible. Then you can apply L'Hopital's rule. Limit as x approaches e, log x derivative is 1 by x, 1's derivative is 0. X derivative is 1, e's derivative is 0. So I will put x as e, 1 by e is the answer. Okay, next question. Limit of e power x minus 1 minus x by x square as x approaches 0. So if you put x as 0, e power 0 minus 1 minus 0 by 0. So you are getting 0 by 0 indeterminate form. That's why we can apply L'Hopital's rule. Limit as x approaches a, e power x derivative is e power x, minus 1 derivative is 0, minus x derivative is minus 1. Then I have 2x. If you still put x as 0, e power 0 minus 1 by 0, you will have 0 by 0. That means you can apply L'Hopital's rule again. So derivative of e power x is e power x minus 1. So what is left, I will write. When I apply L'Hopital's rule, derivative of e power x is e power x. Derivative of 1 will be 0 and derivative of 2x is 2. Now if you put x as 0, e power 0 by 2, that is 1 by 2. The next is what was the previous one? Fifth, sixth, now seventh. Okay, question number 7 I will write. Limit of a into e power x minus b by x as x approaches 0 is 2. You have to find what is a, what is b. So directly if you put x as 0, you will have a into e power 0 minus b by 0. That means both should be zeros. Numerator should also be 0. Denominator is already 0. Numerator also a into 1 minus b should be 0. That means a must be equal to b. That we know it. So I will apply L'Hopital's rule. A is a constant. Derivative of e power x is e power x. Derivative of b is 0. Derivative of x is 1. Now if I put x as 0, I will get a into e power 0 minus 0 by 1. And that is I will have a into 1, which is a. So the limit, I got it as a. But here the limit they got 2. That means I can take a as 2 and b also as 2 because a equal to b they said. The next is question number 8. Limit of square root of 1 plus x square minus square root of 1 minus x square by x as x approaches 0. Immediately after seeing x, you have to rationalize. Multiply the numerator by conjugate root of 1 plus x square plus root of 1 minus x square. Denominator also you have to multiply root of 1 plus x square plus root of 1 minus x square. So when I multiply with conjugate, when I go for rationalization, I'll have limit as x approaches 0, 1 plus x square minus 1 minus x square. Denominator will be x into square root of 1 plus x square plus square root of 1 minus x square. So in numerator, I will have limit as x approaches 0, 1 plus x square minus 1 plus x square by x square root of x into square root of 1 plus x square plus square root of 1 minus x square. So 1 cancels. That means I have limit x square to x square by x into square root of 1 plus x square plus square root of 1 minus x square. 1x will cancel. Now you can put x as 0. 0 by root 1 plus root 1. That is 0 by 2. It's only 0. The entire answer will become 0. Okay, question number 9. Limit of 2x cube minus 4x plus 7 by 3x cube plus 5x square minus 4. As x approaches infinity, you will be taking highest power of x and write the coefficients 2 by 3. 2 by 3 will be the answer. Question number 10. Limit of mod of x minus 3 by x minus 3 as x approaches 3. So this mod of x minus 3 by x minus 3 is a piecewise function. It is x minus 3 by x minus 3, that is 1 if, because they are talking about x approaching 3. So I have to say if x minus 3 is greater than 0 or x is greater than 3. Similarly, the other one will be minus x minus 3 by x minus 3. So that means this will be equal to minus 1. And this happens when x minus 3 is less than 0 or x is less than 3. So if you take limit of x minus 3, mod of x minus 3 by x minus 3 as x approaches 3 minus, that is the left side of 3, x is less than 3, the limit will be minus 1. But limit of absolute value of x minus 3 by x minus 3 as x approaches all the values, as x approaches infinity, we can't take. So we will take the right limit. X approaches 3 plus it is 1 because x is greater than 3. You can see left limit is not equal to right limit. So we can say limit of the function as x approaches 3 does not exist because left limit is not equal to right limit. Okay, we will go to the next question, 11th question. In question number 11, limit of 6 power x minus 3 power x minus 2 power x by 1 by x square as x approaches 0. So I will make some changes in the limit. 6x, I will write 3 power x into 2 power x minus 3 power x minus 2 power x plus 1 minus 2 power x plus 1 by x square. Like this you can write. Now why I'm writing like this? Because I have to take common. Out of these two, if I take common, 3 power x, I have 2 power x minus 1. From these two, if I take minus 1 out, I'll have 2 power x minus 1 by x square I have. So now when I take 2 power x minus 1 common, I have 3 power x minus 1. This by x square I can take separately. So here I will be using one formula, that is limit of a power x minus 1 by x as x approaches 0 is log of a. So using that formula, in this question I will have this is log of a, that is 2, which you will multiply with log of 3, which is 2 true again. So this is how we get log 2 into log 3 for this limit. Next one, limit of 1 minus cos 2x by cos 2x minus cos 8x as x approaches 0. I can write 1 minus cos 2x as, directly I have a formula 2 sine square x, and denominator there is a formula which I will be using, and that formula is cos c minus cos d. So the formula is minus 2 sine c plus d by 2 sine c minus d by 2. So this formula we will be using now. So when I use this formula, I'll have minus 2 sine c plus d by 2, 10x by 2, 5x. Sine c minus d by 2, minus 6x by 2, minus 3x. So first of all, 2 and 2 cancels. Now I can write limit x approaches 0, sine square x by minus will come out. So minus and minus will be plus, sine 5x, sine 3x. This is what we have. Now what I will do is, on the top, I will divide by x square. Bottom also, I'll divide by x square. Moreover, here I will multiply 5 and divide 5. I'll multiply 3 and divide 3. So that I can write limit of sine x by x whole square by 15 into sine 5x by 5x into sine 3x by 3x. So as per the formula, this will become 1, this will become 1, this will become 1. So my final answer will be 1 by 15. So in this way, we did many problems. We will do more problems in the next class. Meanwhile, be more prepared. With this, we will end the class.